Satellites live beyond the Earth's atmosphere, far out in space. The SES global companies and partner companies operate over 40 satellites around the world, and each one orbits the Earth at an altitude of 36,000 kilometers. That's about 1/10 of the way to the Moon. In order to deliver the spacecraft into orbit safely and with the utmost precision, you really do need rocket science, the most advanced space technologies, the highest technical skills and experience, and a fair amount of sheer power. The SES global companies use a variety of rockets from the world's leading providers of launch services to get their satellites into orbit. Ariane rockets launched from the European Space Center in French Guiana, and Proton rockets launched from the Russian Cosmodrome in Baikonur. In the USA, Atlas and Delta rockets are launched from Cape Canaveral. The satellites are carried in the rocket's nose cone, just a small part of the whole launch vehicle. The rest is composed of engines, control devices, and mainly fuel to generate from 500 to over 1,000 tons of thrust to power the huge rocket into space. Each launch vehicle has an individual flight profile, depending on the number and the size of its stages. As each stage completes its task, it is jettisoned as the engines of the next stage begin to fire. Once the launch vehicle has left the Earth's atmosphere behind, the nose cone fairing is also jettisoned. So, much less weight to carry, but still a long way to go. When the last stage of the rocket has completed its burn, separation occurs and the satellite is set free in space. In an Ariane launch at about 20 minutes into the flight, the satellite is delivered to an injection orbit, which is a giant ellipse. The satellite sweeps around it as far away as 36,000 kilometers and as close as a few hundred kilometers. With perfect timing, at the apex of this ellipse, the satellite's own apogee motor pushes the spacecraft into a final circular orbit. This final orbit is a geostationary orbit, which means that the satellite will always stay above the same point on the Earth's surface. The one launch vehicle that can take the satellite nearer to its destination is the Proton rocket. Its fourth stage performs multiple burns, delivering the spacecraft much closer to its final geostationary orbit, about 6 hours and 40 minutes after liftoff. Once the satellite is positioned in geostationary orbit, the giant solar panels are deployed to generate electrical energy and the antennae swing out. From control stations down on Earth, the thruster systems, power systems, communications and control systems that allow the spacecraft to maneuver out in space are all tested for reliable operation. And the payload, the transponders, antennae and associated equipment which receive signals and relay them to Earth are also fully tested. Once all systems are confirmed as fully operational, the satellite is drifted to its final position, where it will begin its operational service in space. The planning and development cycle of a satellite, from conception to launch, extends from 2 to about 5 years and involves substantial investment of know-how, experience and technology. The SES global companies ensure, therefore, that every effort is made to minimize launch risks. Highly specialized engineers monitor the technical developments in the launch systems area, working with the key providers around the world to make sure that only the most reliable and secure launch systems are used for our satellites.